So in this video we're going to look at the idea of ratios. We're also going to talk briefly about fractions, but that won't be until really part 2. So we're going to use fractions, but important not to confuse fractions with ratios. Fractions are a type of ratio, but ratios aren't a type of fraction. Okay, so fractions, if you like, are a special kind of ratio, and it can be very easy to confuse the two. So we're not talking about fractions, we're talking about ratios. Now let's start with a very straightforward problem. So let's say we had, problem A, let's say we had 21 people in a room. 21 people then. And we think that, well, we know that 2 to 5, there's a 2 to 5 ratio of men to women. So there's a 2 to 5 ratio of men to women. So how many men are there, or how many women are there altogether? Well, to solve a problem like that, let's start by first thinking about if there were 7 people in the room. Now, if there were 7 people in the room, let me use a different colour here. I think we would know that 2 of them would be men, and let's use a different colour here, and 5 of them would be women. Okay? So 2 of them are men and 5 of them are women. If there are 21 people in the room, well, the proportions are going to stay the same. So how many men and women are there? Well, we can draw that out very simply like this. So now what I've got are 3 rows of 5, so I've actually got 15 women. And if I complete the pattern, in other words, give myself 2 extra rows of men as well, this should add up to 21. Let's see if it does. So we've got 1, 2, 3, 4, 5, 6, 7 by 3 rows, so 7 by 3 gives us our 21. And you can see that we've now got 6 men and we've got 5, 5, 5, 15 women. So in other words, what we've done, here we go, is we've said for every 2 men, what we can say we've done is we've added another 2 then and another 2 until we've got the same amount as we would have on the other side. So we've got 5, add 5, add 5, giving us a total of 6 and 15. So it's now 6, so 2 to 5 has been scaled up to become 6 to 15, and that means we must have 6 women, 6 men rather, and 15 women. Okay, so we can do it visually, but we can also do it numerically. And in a moment, we're going to use a bit of very simple algebra, which will make it easier again. So that's the basic idea. Let's have another go with slightly different numbers. Let's this time have 35. Let's have 35 pets, just to change things a little. And this time we'll have a ratio of 4 to 1. So 4 to 1. Maybe cats to, let's make that a bit clearer. Cats to dogs. Okay, cats to dogs. So let's see if we can use the same sort of method we had here You could try the visual method as well, but let's just try this method that we have here. So first of all, let's add 4 and 4. Then we've got 1, add 1. Well, that's not going to get us anywhere near 35, so I'm going to add a few more 4s onto this left-hand side and a few more 1s on here. So basically what I'm doing is adding rows just as we did up here. So I've got the same number of rows on the left and the right hand side, but have I got 35 pets? Well, 4 add 4 add 4 add 4, that's 4 4s are 16, add 4, 20, so no I haven't. So I have to keep going. So let's do a couple more. How many have I got so far? I've got 1, 2, 3, 4, 5, 6. Okay, so I have to have 6 on the other side. And now I've got 6 times 4, 24, plus 6 gives me 30. So what was that? 6 times 4, 24, plus 6 gives me 30. So I'm not quite there yet, but I can see that if I add one more, and one more here, I'll now have 7 times 4, 28, and 7 times 1, 7. So I know that I've got 28 cats to 7 dogs. And as a check, always give your answers a check. So we'll just check our answer now. 28 add 7 must add up to 35. So 28 plus 7 equals 35. So we'll say that this is correct. Okay, so that works, but it's a fairly laborious method where we had to really use a kind of trial and error way of working to get our answer. Let's see if we can make this a little bit easier. This time let's have 42 shapes, and we'll divide those shapes in the ratio of, let's say, 1 to 6. So we'll have squares and triangles. So for every 1 square we've got 6 triangles. Now this time what we'll do is think of it in a slightly different way. If I think of what I did here, what I was doing, in fact, I was adding, but basically I was multiplying. As I was working out the calculation, I was saying, well, how many have I got on the left-hand side? So I was multiplying. I had on the left-hand side here 1, 2, 3, 4, 5, 6, 7. In the end, I had 7. And I had to have 7 on the other side. So the magic number was 7. And I multiplied then my 4 by 7 and my 1 by 7 to give myself this ratio 28 to 7. So I need to know, is there an easier way of finding this magic number 7, this scalar 7? Well, I can use algebra to do it, because if I think about this algebraically, I don't know what this number is, so for the unknown I'm going to use, well, let's use S. Okay. So some multiplier S times how many parts I've got, 1, so it's 1S, plus some multiplier, the same multiplier, S, times 6, so 6S. In fact, what we would do is write this, instead of 1, just S plus 6S. So we've got S plus 6S. This must add up to this number 42, because this is exactly what we had here. So S plus 6S equals 42. Okay, now that's very simple algebra, so let's see if we can work this out. S plus 6S, so that's 7 S's. 7 s's equals 42. And rearranging this so I just get s equals something, I divide both sides by 7. So that will make that disappear because 7 divided by 7 is 1. On the other side we've got 42 divided by 7, and 42 divided by 7 equals 6. So this gives me my scalar fairly quickly and simply, and it means now I can convert 1 to 6. So 1 to 6 becomes 6 times 1, 6, and 6 becomes 6 times 6, which is 36. And now to do a check, so let's just check this. If I add 6 plus 36, that comes to 42. So this must be correct. 6 squares then, and 36 triangles, 42 shapes in all. Finally, let's see if we can, I'll just have to make a little bit of room here. So let's see if we can work on a money example. Okay, so we'll have, let's keep the money, let's keep the number the same actually. So we'll have problem D, £42 this time. And we'll have 3 people, let's say 3 girls with £42. We'll have Anna, Beth and Claire. Okay, so £42, and Anna, let's say, has 4 shares. Beth, let's say she doesn't deserve quite as much as Anna, so she gets 3 shares, and Claire, she did most of the work, so it's decided that she'll get 5 shares. So we've now got a ratio that's that hasn't got 2 parts, that's got 3 parts, which means you're not going to see this expressed as a fraction as you do in the fractional form, in other words 1 over the other. You are going to see it in this horizontal way with the colons. Anyway, let's use our method now to work out the answer. If you think you know how to do it, good point to pause the video and give it a go yourself. Okay, so this time we'll have instead of S, we'll have P for parts. So we know that Anna, if we think of Anna first, Anna is going to get 4 parts. So what I want to know is what my P is, what my scalar is that's going to allow me to calculate Anna's parts. Well, we've got, or Anna's share rather, we've got 4P plus 3P plus 5P. Actually, P is not a very good, I'm going to change that because it sounds like pennies. So instead of P, let's have Q. So we use any letter for this. Okay. So we've got 4Q plus 3Q plus 5Q. So that's going to give us 7Q, and that's going to add up to £42. Not 7Q, 7Q plus 5Q, 12Q. Okay, 12Q gives us £42. So what does Q equal? Well, that's going to give us a kind of fraction, because we've got 42 over 12, which isn't going to give us a whole number. So we've got a fractional scalar this time. Let's have a look. What divides into both 42 and 12? Well, that's going to be 6. So 42 divided by 6 is 7, and 12 divided by 6 is 2. So our scalar now is this improper fraction. Okay, so now let's work out Anna's share. So Anna gets 4 times our scalar 7/2, which gives her 4 times 7 is 28, divided by 2, 14 pounds. Okay. Beth, well, she only gets 3 shares, so it's 3 times 7, which is 21, divided by 2 gives her £10.50. And finally, Claire, she gets a whopping 5 parts for her share. 5 times 7 is 35, divided by 2 gives her £17.50. And again, very important we do a check. So our check now is £14.50, sorry, £14 and no pence, £10.50 and £17.50. And we could do this mentally maybe, but let's just do it using the column method here. So we've got 50p plus 50p gives us £1. 4 add 7 add 1 is 12. You can add up just to check. 7 add 4 is 11 and 1 is 12. Add 1, add 1, add 1, add another 1 gives us 4, gives us our £42. So this and this must be correct. Okay, so I said at the start of the video that fractions are a special kind of ratio, but I'm also quite clear that ratios aren't a kind of fraction, so it only works one way. So how do we understand this? How do we make sure we don't get confused between fractions and ratios? And what does it mean that a fraction is a special kind of ratio? Well, let's think about a disk. If I divide my disk into 4 equal parts, then from those equal parts I could take 3 of those parts. Let's take these 3 here and not take that. Then what would I have? I would have 3/4 of my disk. And I think we all know what 3/4 means. 3/4 of the disk is exactly what it says. It's 3 of these quarters, or 3/4. So what do we mean by fourths? Well, this tells us the number of parts. So the number of parts that the whole has been divided into. So the number of parts gives us the whole of the object. Okay, so this in fact is the number of parts that we're taking. Okay, so this is the number of parts that we're taking. And this 4 here is telling us how many of those parts make up the whole. So 4 parts to make the whole and 3 parts to make the size of the fraction. So I hope that makes sense. That's a special kind of ratio. It's a ratio we call a part to whole ratio. Now most ratios, if you think about it, are in fact part to part. So instead of part to whole, they're going to be part to part. So if I think of what I've done here with my dividing up my disk here, I've taken 3 parts and I've left 1 part. And so that added up together will give me my 4 parts, which in this type of ratio is the denominator of my fraction. So let's say, for example, that I'd confused these two different things. And I can write, and we will write in later videos, a ratio like that. But let's say it's 3 to 4, or let's in fact stick to our disk. Let's say 1 to 3. Okay, so the one part that I left here to the 3. So it's a 1 to 3 ratio, because of course we can read from right to left. Order matters, but we can read from right to left. So a 1 to 3 ratio, but let's say I thought it was a fraction. Well, clearly then I would be wrong, because I haven't divided it into thirds. I have divided it into fourths. So that in fact means 1 to 3. It doesn't mean 1/3 as a fraction. So it doesn't mean that. Okay, let's think about 3/4. Again, if I thought that was a part-to-part ratio, then I would think that I had 7 parts. But I don't have 7 parts, I've only got 4 parts, and that's because this denominator here is in a fraction, which is what this is, signifying the whole. It's how many equal parts make up the whole. So it's very important when you see something like this that you know whether it's a fraction, conventional fraction, which is a part to whole ratio, or whether it is in fact a part-to-part ratio and so therefore not a fraction at all. So very important that you understand these concepts. Make sure you understand that fractions are a special kind of ratio, but ratios are not, usually not, fractions.